let's cover relational databases in the context of a Node.js and a mean stack application. So instead of mean, the M in a mean stack application is for MongoDB, right? For NoSQL databases. Instead, let's replace the M in the mean stack with a relational database, right? So it could be, if it's Postgres, then it would be PEAM instead of mean, or whatever acronym you want to put in there, right? To say that that whatever database we're actually using. I've already installed Postgres, and I have here I have a client here that allows me to connect to the database. Where do I have it? Let's see. I think I have it right here. pgadmin3 allows me to connect to the relational database. So relational databases is quite different from what we've been looking at in MongoDB. In MongoDB, we saw that it's a database. It's an object database, right? It allows us to store data in a format that is fairly useful for the for the client that is consuming it, right? It's very convenient because the client is written in JavaScript, right? And it's generating a data stream formatted in JSON format, right? When it gets to the server is also written in JavaScript, right? So the data format is native to the server side as well, right? There's no need to convert any of the representation of the data models, right? And when it's stored in a database as well, it's also stored in the native format. In relational database, it's a little bit different. So the idea of relational databases was to abstract data storage, right? When it first came out, you can certainly write all sorts of code to be able to write or read from a file system, right? Especially if the file system, if the file that you're storing has a particular structure, maybe comma separated or tab separated, you can read and write, iterate over it, searching for things, right? But what SQL allowed us to do, it was to abstract the access of this data from file systems with a language that allowed you to do very common things. Okay, and the abstraction was to think of the data organized in what were called tables, right? And each table would have lots and lots of different rows, where each row represented a data space, right, or tuple that had several name-value pairs, right? That it's very key to what we think of a document in a collection. Yes, right. So instead of collections in a relational database, we have tables. Instead of documents, we have rows, right? And in each row, we refer to it as a record. In a relational database, we have schemas, which we don't have in MongoDB, right? In a NoSQL database, we have instead here we have fields, and each field can have a different data type, right? Some of them could be text, some of them could be numbers, some of them could be dates, right? You have a strongly typed field, right? All these fields have a strong typing, right? And every time we insert something in the database or try to modify something in the database, the data that we're storing or retrieving is always validated against that schema, okay? So that we don't allow bad data to be stored here, okay? And so this table might represent a user, okay? And fields in here might be username, password, first name, last name, email, and whatnot. Yes? And some fields might be compound fields, right? Maybe a field here might be address, right? An address is actually something that's made up of many other things, right? An address might have a street name, a zip code, country, state, and things like that. Yes? And perhaps one naive way that we might choose to store that would be to store it in separate columns for the street, the state, the zip code, and whatnot over here, right? The problem with that is that what if you have a particular user that has many addresses, right? If I have many addresses, then I would have to represent it how? Well, let's see how we could represent it. One way that we could represent it is we have the user, user 1, right? And then in here, we have the representation of address number 1. If we want to represent another address, we could have another record down below, same user, right, but a different address, address number 2. Yes? Okay. A problem that we see right here is that we have redundancy, right? We're storing the user information twice. Okay. And then typically in databases in general, we try to avoid redundancy. Okay. We avoid redundancy because we try to stay away from the risk of inconsistency. Right? We don't want to have something stored more than once because it could be that, depending on how you query, the data could come back in different ways, right? It could be that, right, if we are updating one record, and we're storing some information over here, the idea would be that that value should be the same for all instances of the same user, right? We might forget that we update one, but we don't update the other, right? So we try to eliminate any possibilities of redundancy, right? And the way we do that is by storing, have a table be specific to store one particular type of information. So this will be only user information, and one record represents that one user, and that's the only place where that information for that one user exists, right? And we don't replicate it more than once. Instead, we do something that's called normalizing, right? We normalize the data so that we don't store the address here, but we store it instead in a separate table, right? Maybe the address table, where we have the streets, the numbers, and the states and zip codes and whatnot stored over here, right? And if we want to say that this address belongs to that one particular user, somehow we add additional fields. We add additional fields that allow us to somehow link these things together and say that these two are related to one another. Okay, the data is related, and that's where the name Relational Databases comes from. Right, that we have two records, right, that are really together, right? They should be somehow together, but we split them. We split them into separate tables, right, to avoid redundancy, avoid inconsistency. Okay, and we do this relationship. So if we have another address, we have another record over here, and this same field over here would refer to the same person over here. Make sense? Okay, and we call these additional fields. These additional fields have specific names. We call this the field where you have the single instance here. We call this the primary key. Okay, key meaning that this is uniquely identified. That user is uniquely identified by this unique key, right? That represents this user. And you have these referring to those primary keys. We call them foreign keys, right? Foreign keys. That the values here. The values of these foreign keys are the values of some primary key living in another table. Make sense? All right. Notice that this is not the way you would represent it in an object world, right? In an object world, you would use something like an array, right? You have a person, and if that person has many addresses, then you represent it as an array of addresses. Yes. Notice that it's kind of thinking about it backwards, right? If you have a class user and you have a class address, right, so this is a class, you would have an array of addresses, right? It is the parent user who has references to the children addresses. Make sense? Right? It is not the addresses that know anything about the parent user. Make sense? But notice in relational databases, we think about it backwards. Right? The parent has no idea who their children are. It is the children who know about the parent. See that? It's kind of up. It's kind of backwards, right? Relational databases were not originally intended for object orientation. They don't support many of the new features of inheritance and all these complex data types, and allowing data types being able to include other data types, including other data types. So we don't have any of that hierarchy, right? It's a very flat implementation. right? The only way that you can build these hierarchies is by having these relationships, right? These things pointing to each other. Make sense? Everybody okay? All right. Typically, we record this type of diagram. We record it using or we represent it using a diagram language called UML, right? And we would use something like this. You have a user and an address, and we represent it like this. One user has many addresses, okay? And there are tools that allow you to drag and drop these boxes. You type in all the fields, there are data types. You push a button, and it generates all sorts of code for you. Okay, a boilerplate code that you can then go in and fill out. Right. All right. So let's look at another example. Here you might have this might be an actor, right, and this might be addresses, right. An actor having many addresses, that's not uncommon, right? A house in Beverly Hills, a house in Europe, a house over in the East Coast. And then that actor might play different roles in different movies, yes? Right? And so you might want to represent that by having something like this, where you have a many-to-many, right? One actor can play many roles in a particular movie, or one particular movie can have relationships with many actors, yes? So this would be one way to represent this, or draw it, saying many actors are related to many movies. But this actually can't be implemented, right? Because, right, if you go back to represent this in a relational database, right, you would need to have a field here somehow. You have to have a field here of primary keys and foreign keys. This would have to say that one record, one particular movie, would have to have many foreign keys pointing to many actors. We don't have that. Databases don't support that, right? Where you have a collection of foreign keys, like for instance we do in Mongo. In Mongo, it is perfectly fine to have an array, right, of keys, right, of IDs that reference other things. Yes, that's perfectly fine in object orientation, but not here. Databases don't support that. So the only way that we'd be able to have this kind of mapping backwards and forwards is to have a separate entity right here that maybe we can call it something like casting. It's a cast. You're saying these actors were casted for these roles in these movies. Yes, right. That says that these actors over here, right, were casted in a particular role for that movie over there. Right now you can have here maybe 3 columns. One for saying what actor in what movie and what was the role in that movie, right? Where the actor is a foreign key that points to a particular actor. Here is a foreign key that points to a particular movie, and then says that the role is, they were the flying monkey, whatever. Okay, and so now you can have the same actor pointing to many different types of movies, right? Different movies pointing to movie 1, movie 2, movie 3, right? And then one movie maybe pointing to many different actors, right? The same movie pointing to the different actors. So now you can create all these many-to-many relationships, right, of many actors related to many movies. Make sense? Right? Sometimes this is referred to as a mapping table that maps instances of records in one table to instances of records in another table. Right? Oftentimes, this is in a UML class diagram. It's oftentimes referred to as an association class, because not only is it associating instances, but it's also describing that relationship, right? Like adding information, meta information about that relationship. Make sense? So let's prowl around that. Let's build something real quick that we can build here. Let's see. Let's create a create a schema for this class. We'll call it webdev spring 2017 evening. And let's create here a couple of tables. Let's see, new table. Let's create an actor table. Let's create a movie table. And let's create another table called the casting table. Okay, and the actor, we're going to define the columns in the actor. So let's create a couple columns here. A new column will say maybe the name of the actor, and we'll say the type is text. We'll also create the primary key that uniquely identifies each record, right? That we get for free in MongoDB, right? The underscore ID, we get it for free. We don't have to do anything, right? We get that primary key for free, underscore ID. Here, we have to create it. We'll say new column. We'll say that's an ID. And you can give it whatever name you want, okay? Here, we're going to say it's serial. Serial, meaning that I don't want to, I want to make this unique, right? This field should be unique. And I want you to deal with it, right? You handle the value of this field, right? You make it unique. And what it's going to do is just every time we insert something in the database, it's going to just increment this value 1, 2, 3, 4 for every record that we add. Okay. Let's see for the movie, we'll do something similar. We'll say new object. We'll say new column. We'll say that there's a name for the movie, and that's text. We'll add another column here. We'll say new column. We'll say that also we'll call ID will be serial. Right, that uniquely identifies the name. Well, actually, instead of name, let's remove that. We'll drop. Right, we'll say title. How about it's better? The title of the movie. So new column. We'll call it title, and that be. What? Did I say Siri?
Checking on that.
No, don't.
My web's.
There we go. Quiet. Okay. All right. So movie has a title, it has a primary key. All right. Everybody okay? We're still with me? All right. The other one will have casting. We'll create a couple columns here. Certainly the ID that uniquely identifies this. We'll create also. We'll create a column that is going to tell me the role, right? The role name. And that will be text, right? Very good. And we'll add a couple more. So another column that we're going to add here is references to these two guys, right? We're going to say we're going to have a reference to the actor and a reference to the movie. So we're going to be holding the actor ID, which is going to be an integer, and we're going to be holding here another column here. New column will be the movie ID. That is going to be holding an integer no. Hello? Why can't I remove this? What the?
It's date type. You need to append.
Wait, so this is movie underscore ID integer. Thank you. There we go. Okay. All right. So basically we're almost done, right? That's all we really need. And we can start adding actors and casting in movies and making sure that these values match, right? That the IDs that I put here for a movie or an actor matches the IDs for the real actor. See that? Right? As long as I'm careful, right? I'll make sure that the values match, right? That actor 1 Arnold, right, is added to is related to the movie Predator, right? And make sure that the IDs match and whatnot, right? If I make a mistake and I add Arnold to a movie that doesn't exist, or the IDs I somehow mess up ID number 1, 2, 3, Arnold will be added to a movie that doesn't exist, right? And the database will be happy to just let me be, right? But instead, what I like for me to do is that the database catches those errors for me, right? If I try to associate a non-existing movie to an existing actor, I like the database to let me know, hey, that movie doesn't exist, or that actor doesn't exist, right? So to do that, we're going to tell the database to please verify these things for me, right? And to do that, we're going to use constraints. We're going to say, hey, primary key, hey, database, I'm gonna tell you that the ID field, is a primary key. It's a primary key, right? So I've added the actor ID as a primary. I'm telling you that somebody's going to reference you. Somebody's going to reference you. Make sure, right, that things match. Okay, that things match. Same thing. We're going to go with the movie. Same thing. I'm going to say ID is also going to be a primary key. So I'm going to say new primary key. I'm going to tell it that column ID is a primary key. I say OK. Right? Because remember, this one, the casting table, is going to reference movies and it's going to reference actors. Yes? I want to make sure that that is consistent. This is called, in relational database, is something integrity. Referential integrity. Right? That the references, right? There's referential integrity, right? So for instance, if I have one actor associated to many addresses, right, and I try to remove the address, the actor, then the addresses would become orphans, right? Because they're all referencing that actor. You know, what happened to all the houses in Beverly Hills and New York and Europe? They're going to be left without an owner, right? If I remove the actor. So the database is going to stop me and say, no, you have all these children that are referencing the parent. You can't remove the parent without removing the children first, right? So that you achieve that by telling the database these hints. Same thing for the casting. We're going to say that the actor ID and the movie ID reference those other fields over there, okay? And by adding these constraints, we're going to say add a new constraint. We're going to say I'm going to add a new foreign key. The column is the local column. Actor ID is going to reference this field here. No, that's not it. It's evening. That's actor, right? Actor. There we go. And it's going to be referencing the ID. And we're going to give it a name. This is going to be the actor foreign key. Evening actor foreign key. Column. Am I missing something? Add. Okay. And then I'm going to add another one, another foreign key, and I'll call this the evening movie foreign key, and the column is the movie that I just created. There we go. It's going to reference the ID, the primary key there, and it's going to be referenced by the movie ID. I'm going to add. Okay. All right. I think I'm done. Let's see. The actor. Okay. I think. Did I have the constraint correctly? Is it referencing the right thing? Wait, let me see. Actor primary key. Okay, very good. I think we're all set. Okay, so we're ready to start adding things. So to do that, we use a language called SQL that has been around for quite a while. It has served us well. It will still serve us well for quite a while, but certainly is being superseded by new and better ways to interact with databases. So let's do some data manipulation. So to do that, we can ask the database to give us some hints on how to insert things. So notice that it shows here a couple of template scripts, right, for being able to do the various CRUD operations, right? We can create, right? Insert is for creation. Select is for reading. Update is for updating, and delete is for deleting, right? The 4 CRUD operations. That's all you can really do, okay? So let's do an insert. And so it creates here little templates. Let's copy that. And let's create a new, so you can see better here. Let's insert into the actor. And notice that I have declared the ID as a serial, right? And so that means that it's going to automatically select or choose a key for me, the value for that ID. So I'm not going to, that's optional. I'm not going to give it the ID. So the name of the actor will be maybe Arnold. Oh, sorry. No, this is names. This is name, and then the value is right here, Arnold. Arnold. And let's create a couple of these. So let's create 3 actors. So this will be maybe Harrison Ford. Harrison. And who else? Liam Neeson. Okay, so let's add those three actors. Let's go back and let's paste it in here and execute it. Looks like it worked. Let's now retrieve this from the table. So we can use select star from, and then the table we want to select it from. There it is. Right. So this says read all the records from this table. Right. So let's retrieve that and let's paste it in here and let's run that. And it comes back with the data that we just added. Right. Arnold, Harrison, and Liam. Everybody okay? All right. So let's do the same thing with movies. So let's add here an insert script and let's copy that. And let's paste it here so we can play around with it. And I don't really want the title, and the value is right here. So the values might be, let's see, let's add a couple of movies. Arnold, Terminator 2. Well, The Terminator, I guess. The Terminator. What else? Judgment Day. Judgment Day. Okay. What was that alien movie he was in? Predator, was it right? Predator. What? That's Predator 2, okay. As for Harrison Ford, we'll add maybe, let's see, Blade Runner. And Indiana Jones. What else? Anything else is done? Ender's Game. I don't like the first book. And Liam Neeson, we can have maybe Taken 1, Taken 2, Taken 3. I guess he was a very bad parent. So let's grab those three and let's insert it here. We have here, and so we'll paste it in here, and just execute just these three. These 9, and then select all the movies from here. So we'll do something like select star from, and then the table is this one right here, movie. And we can have that, right, and just execute that. And there they are. There's the 9 movies. Then we can create the relationship between these movies, right? And the way we do that is by referencing these IDs, right, from the movies and the IDs from the actors inside of the casting, right? So let's do that. Let's do an insert inside of the casting, and we can copy that and add it here. So we don't really care about the ID. We only care about the role, the actor ID, and the movie ID, right? And we'll put it in the values right here. Let's see. We don't want the first question mark. So role. Let's see. We can have Arnold. What was he playing in Terminator? I guess he was playing the Terminator, right? And movie ID, I guess 1, and actor also number 1. Movie ID 1 and 1, right? In the second movie, which is the Judgment Day, is also playing the same exact character, so the Terminator, and that's the same actor, number 1, but the movie is number 2. And finally, he was playing. What was he playing in Predator? One of the guys. What was his name? Where's the Predator? Predator. This one. What was his role? He was Dutch. Really? What a crappy name. Okay. So this is the role, and for movie number 3, right? So if I select that and I insert it here, let's close that, and I execute that, it'll create relationships for those 3. And let's look at all the casting. So I can retrieve all the casting that I have so far from casting, right? And and see that we have the role here, and then the pointers that go off to the actor and the movie, actor, movie, right? But these numbers are really not very useful for me, right? They're just numbers, right? Only if I could somehow recreate the original information, right? For me, for convenience purposes, it'd be great if I could have the information that is spread across, 3 different tables, right, that are related to one another, like that with actors and casting and movies, right? The only reason we spread it across 3 tables in the first place because we are following the policy of denormalizing the data, right? Splitting it out so that we don't have any redundancy. But more conveniently, we would like that to be all joined together, right? It will have just one large spreadsheet where I have, the information about the actors perhaps in a set of fields here, the casting over here, and maybe the movies over here, right? So one thing is how convenient we want to consume the data and how we actually are supposed to store it, right? They're not necessarily to be the same. So to accomplish this in a relational database, what you do is that you basically have to match, right, these foreign keys and primary keys together to reconstruct the data in a usable format, right? I like to see the actor's name, the movie name, and the role that they played, right? These numbers really are not very convenient, right? So we need to join everything together, okay? And something that it's not supported in MongoDB, right? We saw that the closest thing that we could do in a join was to do a populate. Remember we did populate, right? We had we had users referencing arrays of websites or things like that, but the only thing that we had were IDs, very much like these foreign keys, right? But the IDs really didn't do anything for us, right? We actually wanted the object, right? To retrieve the object, we needed to do a populate, yes, right? So I told you back then that was the closest thing to a join. So let's look at what a join is, how to actually implement a join. So basically what I want to do here is I want to select a whole bunch of information. I want to grab the name of the actor. I want to grab the title of the movie. I want to grab the role that they were playing in that movie, right? What actor was playing in that movie. But these 3 pieces of information live in 3 different tables, right? So I need to somehow grab everything from various tables, from the following tables. One of the tables is the actor table. Actor. The other table is movie table, and the other one is the casting table. Yes, and if I do that, right? If I do that and I paste it here, right? It's not exactly what we would expect, right? If I run this, notice that I think we're getting much more information than we would expect, right? Basically, what it's doing here, right? It's looking at all the actors, right? It's combining them with all the possible movies, and those combinations then recombining them again with all the casting. So here, what we're getting is all the possible combinations of all the data in one table combined with all the data in the second table combined with the third table, right? It's like a cross multiplication of all the possible data points that we have, right? And notice that some of them just make no sense, right? Here we have Arnold related to the Terminator. Well, that makes sense, right? The Terminator. And Arnold with Judgment Day, Terminator, that makes sense. Arnold with Predator, that makes sense. But Arnold with Blade Runner, the Terminator, that makes no sense, right? Right. So we need to filter out and say, hey, most of these don't make sense, right? The only ones that do make sense are the ones that match the criteria based on the casting I created earlier, right? Of telling you of what actor was in what movie. Yes? So we need to follow those pointers, right? And the way we do that is by providing a filtering where clause, right? A where clause is very much like in the finder method, right? Where we provide an object as a filter, and there we can put a criteria by which we want to filter the things. Yes? Right? The records that we want. So here we can say, well, I don't want all the combinations. I only want the ones that make any sense. So for every actor, I want the IDs that match a casting, that there is a casting, right? So here's the casting, the actor ID, and that the casting and that there is a movie that matches that, right? We have movie dot ID matches the same entry in the movie ID over here. Okay, so now this makes sense, right? I only want the ones that have this criteria, right? If we put this in there in our query, right, and we run this again, then notice that we only get the ones we do care about, right? The ones that do make sense. That there's Arnold in the Terminator, playing the Terminator, or Judgment Day, or Dutch in Predator. Make sense? Everybody okay? All right. So here we have being able to store things in the database or remove or retrieve things from the database. Let's see how we can do this programmatically from outside. Okay. So let's go to Node.js, and we'd like to be able to programmatically interact with the database. So to do that, we need to store we need to install a plugin that allows us to talk to the database, right, and communicate with Postgre, right? Just like we installed Mongoose. Mongoose was the library that we're using to communicate with MongoDB. Right? We need something similar to talk to Postgre, right? So to do that, we can go to npm, and there's one particular library in npm that's called PG, or Postgre, right? That allows us to talk SQL with Postgre, right? So to do that, we can just say npm install PG, right? And it will install the library. Then internally, we can require a Postgre client to be able to talk to the Postgre database. So let's do that. Let's create here a directory where we can play around with Postgre. We'll say new directory Postgre, and create here a file or a directory where we can have models, right? That deals with the database. Let's create a JavaScript that communicates with the underlying library by requiring Postgre. There we go. We have Postgre. And let's connect to the database, right? Let's connect to the database. So to do that, here Postgre in the documentation says that you can create an instance of the client, all right? And then you can connect to the client. Okay? And that's it. You're connected to the client. But you need to be a little more specific than that, all right? We need to say, well, there's a whole bunch of databases in there, right? There's usernames and passwords, and you need to log in, and where is the database running, and things like that. To do that, we can create a configuration file, a configuration object. There it is, which we'll use right here. And then we can pass that configuration object when we instantiate the client, right? And in the configuration object, we can specify the username, the password, the database that we're communicating with. The username here is Annunziato J. That's me. So let's say Annunziato J. The database, I believe, is the same name. No, wait. Oh, is it the schema? I think it's the schema. Let's see. Webdev, spring, 2017, evening. Okay. No password. I didn't put any password. It's connecting local to this port and whatnot. Everybody good? All right. So let's and then let's do a console log client to see if we are actually connected. Well, actually, wait a minute. I think we can run when we connect. When we connect, we can give a function to see if there's an error. We can listen in for the connect if there was an error. Let's see. This one is that function. If error. Am I missing something here? Let's see. Looks like I am. Wait a minute. Client, connect, error done. This one is right here. The function. What is my error? Function if. Oh, okay. I need to close that and that. Okay, very good. All right, so let's run this from the command line. So this is in PWD. Let's go into lectures Wednesday, and this is Postgre and models, and there it is, client. So let's run client. Let's see. Oh, looks like they're fetching error database not found. Looks like the database then it's just the name, my name. Let's see. Let's try that again. All right, it's connected. Okay, so that's the database name. Very good. All right, so let's keep playing around. We have connected to a database. We're going to export the client so that we can use it outside of this file, right? We're going to do module.exports, right, equal client so that we can use it outside, right? Let's create here a model that can connect to the actor. We'll say actor .model server JS, right? And here we're going to require the client. So let's grab the client that we just created from the file require from the file client. There it is, right? Also, we're going to need a queue. We require queue, right? And so, like many of you are doing, right? We're going to use queue to be able to handle the asynchronous communication. All right, so let's see. What can we do? We want to be able to retrieve all the actors. Let's do that. Let's create a function here that find all actors. Right, and to do that, we're going to say client and retrieve all the actors. Right, to do that, we're going to need a SQL, an SQL string. Let's create the SQL string. I think we have one already, right? Don't we have one that retrieves all the actors? There it is, right? We have this. Select all the actors. There it is. So let's put that in there. There it is. We have the SQL statement, and we can just execute it. We can say client dot query and pass the SQL command, all right, to select all the actors. And very much like Mongoose, right? This will be asynchronous, right? It will call us back with either an error or a result set. All right, so let's do a console log and look at the results that come back from the database. So results. Okay, so let's run this. Let's say find all actors. So let's run it from the command line. Where are we? Models, and let's say node actor movie. There it is. So it came back from the database, and it says that there were 3 rows that came back from the database. Oh, I can't make it bigger. Sorry. It says that there were three rows that came back from the database. The 3 actors, there they are. The data is actually stored right here under rows. See that? Rows and the 3 rows. And the fields are there, Arnold and whatnot. Also notice that the schema is returned to us, right? Saying that there are 3 fields in there. There's an ID field, there's a name field, also the data type, right? I presume one means that it's an integer, the other one means it's text. All this metadata can be used by a client, right, to be able to render this properly in a table format. Okay. All right. So very good. Let's do a couple more things here. Let's create be able to create an actor. Create an actor. Presumably is an object that you're going to pass us. So this is the actor object, and we need to insert that, right? So let's we have an insert right here that we can use. Let's copy that. And so the SQL statement is going to be something like that, right? Where the actual data over here, we're going to take it from the object that we are passing in, right? So here's the name of the actor. Once we have that string, we can execute the query, the SQL, and then we're going to return the result set from the database, right? So we can say console log and then the results from the database, right? So let's create yet another actor. So we'll say create actor, so Will Smith. Okay? So it needs to be an object, right? The object is going to be that this is the name of the actor. Okay, so let's run this from the command line again. Right? And notice that what comes back is a metadata describing the results, the status of the last command. The command was an insert. There was a row count, right? Meaning there was one row that was added. Okay, so we get some result set, right? And we can always go back to the database and query to see that indeed that information was added. So we can query over here all the actors, and we see that Will Smith was indeed added to the table, to the collection or the table. Make sense, right? Let's do something similar for the movies, right? So instead of actor, we'll have maybe movie model, and in the movie model, let's replace everything. Notice that I'm not going into other statements such as delete or update, okay? But it just give you a flavor how you could interact with a NoSQL. With a SQL database, right? So here, let's replace this actors. Let's replace actors with movies. So this will be actors, movies. So replace all. Let's see. Instead of actor, we're going to replace that with movie. So replace all. Let's see. Instead of name, I believe this would be a title, and this would be movie title. Let's see if we can create. Wait, why didn't this change? Wait, actor. Why didn't this change? That makes sense. That's weird. Actor, movie, replace all. Okay, so let's create. Let's see if we can find all the movies. Let's find all the movies. Let's run this from the terminal. We'll say node movie model. There they are, right? We have all the movies that were added here. Okay, and we can create a brand new movie here. Let's see. Let's add here. What movie was Will Smith in? Men in Black. What? Oh, Suicide Squad. Okay.
Yeah.
So presumably we're able to add it. Let's query to see that make sure that the movie actually made it in there. Undefined. So Suicide Squad is undefined. What did we do wrong? Oh, instead of name, it's actually title, right? Let's try that again. And let's query again. And it's still not there. What's going on? Suicide Squad is refusing to go in there. Fine. Oh, wait, okay. Fine. Create movie. Create movie goes here. Create movie. Evening movie title. Movie title. Query. What's going on? What is going on? Wait a minute. Terminal. Oh, okay, worked. Sorry, I clicked on the wrong button. There it is. There's Suicide Squad. Everybody okay? All right. And all right. So this is just a flavor. Obviously, you would sandwich this inside of a queue promise, right? You would return the promise in the service. You would then use those promise to register a callback, right, to be able to answer back, right? So I'm not going to go much further into this. I think this gives you just a flavor on how you would be able to interact with a relational database. All right? Okay.